A recent discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, the well-known science communicator, made headlines when he announced that Voyager 1 had detected over 300 massive objects in space. This revelation not only ignites our curiosity but also raises profound questions. What exactly are these objects, and where did they come from? This mysterious finding is just the latest in a long list of astonishing contributions made by the Voyager missions. Launched in the summer of 1977, Voyager 1 and Voyager 2 were initially designed for a 5-year mission to explore Jupiter and Saturn. Surprisingly, the missions have lasted far longer. Thanks to a groundbreaking idea by Michael Minovich, using a planet's gravity to propel a spacecraft further, these missions went on to explore more than anyone could have expected. Voyager 2 later became the first spacecraft to conduct close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of 4 giant planets earned the mission the name, Voyager Grand Tour. Rather than ending there, the spacecraft were directed towards something far more ambitious, the exploration of deep space. Today, nearly 5 decades later, both Voyager 1 and Voyager 2 are still traveling through the cosmos and transmitting data back to Earth. In 2013, Voyager 1 made history by becoming the first human-made object to enter interstellar space, the vast region beyond the Sun's magnetic influence. It was followed by Voyager 2 in 2018, each now tens of billions of kilometers from Earth. They remain the only spacecraft to have crossed the heliopause, the invisible boundary that separates the heliosphere, our Sun's protective bubble, from the rest of the galaxy. The heliosphere, shaped by solar wind, acts as a barrier against harmful cosmic radiation. As the spacecraft moved beyond this boundary, they provided crucial information about the transition into interstellar space. One major finding was that cosmic rays, high-energy particles from the galaxy, are much more intense outside the heliosphere, like stepping from a quiet backyard into the middle of a bustling city street. This discovery was just one of many surprises awaiting in the cold, quiet wilderness of space. In 2023, Voyager 1 made another unexpected discovery, a low-frequency humming sound. This gentle vibration, detected in the sparse interstellar gas, hinted at the presence of unseen forces at work in the void. Nicola Fox, head of NASA's Heliophysics Division, highlighted the importance of the Voyager missions in transforming our understanding of the Sun and its environment. Despite being powered by decaying plutonium, a fuel that produces less and less heat over time, the spacecraft are still operational. To conserve energy, NASA has shut down many non-essential systems, including heaters. Yet against all odds, all 5 key instruments on Voyager 1 have continued to function since 2019, even in freezing temperatures where most spacecraft would fail. This resilience has left scientists astonished. More mysteries emerged when researchers began studying the heliopause more closely. Far from being a fixed boundary, it appears to shift in shape and size, reacting to solar activity and galactic forces. Over the past decade, Voyager data combined with NASA's Interstellar Boundary Explorer, IBEX, has shown that the heliopause bends, moves, and changes unexpectedly. In 2014, IBEX detected an unusual surge in energetic particles, suggesting turbulence at the edge of the solar system. These changes could explain why Voyager 1 entered interstellar space 6 years before Voyager 2, even though both were headed in roughly the same direction. Such irregularities challenge long-standing models and have left scientists re-evaluating what we know about the Sun's outermost frontier. Then, in May 2023, Voyager 1 encountered another strange event. Its Attitude Articulation and Control System, AACS, which controls the spacecraft's orientation, began sending back confusing, incoherent data. It was as though Voyager 1 was suffering from a kind of digital disorientation. Yet curiously, the spacecraft's antenna remained perfectly aligned with Earth, and the rest of its system seemed unaffected. NASA eventually discovered that AACS had started using a long-dormant computer to process data. A command was sent to reroute communications through a working unit, restoring normal function. But what caused the glitch in the first place remains unknown. NASA suspects that a faulty command from another onboard system may be to blame. These incidents are reminders of the extreme challenges the Voyagers face. After all, these spacecraft are still running on 1970s-era technology. Each has just 70 kilobytes of memory, less than a basic calculator today. And yet, despite being so outdated, they continue to operate. High-energy particles in space can interfere with the spacecraft's electronics, causing occasional errors. Still, engineers at NASA continue to keep these ancient machines running, sending software updates and commands across billions of kilometers. This is cosmic maintenance on an unimaginable scale. But the legacy of Voyager is not just about survival. These missions have transformed our understanding of the planets they visited. Thanks to Voyager, we learned that Jupiter is a storm-ridden world with glowing auroras and mysterious rains. Saturn, once thought to have a few plain rains, was revealed to possess thousands of intricate ringlets, some braided in ways once thought impossible. Voyager also discovered active volcanoes on Jupiter's moon Io and nitrogen geysers erupting from Triton, Neptune's icy moon, where temperatures approach absolute zero. Perhaps most astonishing were discoveries that hinted at the possibility of alien life. Voyager found strong evidence that Jupiter's moon Europa and Saturn's moon Enceladus likely harbor oceans beneath their icy shells, liquid water worlds that may be capable of supporting life. These findings have become key targets for future missions. One of Voyager's most poetic moments came when it looked back at Earth for one final image. At the suggestion of astronomer Carl Sagan, the spacecraft turned around and captured a photo of Earth from more than 6 billion kilometers away. That tiny speck, known as the pale blue dot, offered a humbling reminder of our place in the universe. From such a great distance, our entire planet appeared as nothing more than a grain of dust suspended in a sunbeam. Today, it takes over 22 hours for a signal from Voyager 1 to reach Earth, and nearly 19 hours for Voyager 2. Each day, they move about 3 to 4 light seconds farther into space. NASA's Deep Space Network, with antennas spread around the world, keeps communication alive, ensuring that even the faintest signals are not lost in the noise of Earth's technology. The Voyager missions were made possible by a rare alignment of the outer planets that occurs only once every 176 years. Scientists like Michael Minovich and Gary Flandreau recognized that this alignment could allow a spacecraft to slingshot from one planet to another, reaching Neptune in just 12 years instead of 30. Though budget constraints forced NASA to scale back its original plans, the Voyager probes have more than exceeded expectations. Nearly 50 years after launch, Voyager 1 and Voyager 2 remain humanity's most distant explorers, continuing to unlock the secrets of interstellar space. Their legacy is one of perseverance, brilliance, and curiosity, reminding us that even the most ambitious dreams can become reality when we dare to explore the unknown. Let us know what you think in the comments. If you enjoyed this deep space journey, don't forget to like the video and subscribe to Discovery at 2.0 so you never miss our next cosmic adventure.